Hello my students, now let us proceed with today's lesson. Our today lesson is concerning about description of a wave. In description of a wave, we're going to look on different physical quantities which tries to explain what is the wave, or what are those properties of the wave. Now today's lesson is describing of a wave. That means we are going to look different physical quantities which describe a wave. Now in describing of a wave, we are going to take a wave as with a transverse shape. For us to describe a wave, we are going to assume a wave has a transverse shape. We're going to assume a wave look like this way. A wave look like this way. This does not mean that the transverse waves is the only waves we have. No. This is to bring about simplicity of the concept you are going to talk on. Remember, we have different kinds of waves. But what we are going to define here and using the transverse waves is the ones which we are going to imply in all categories of waves. Therefore, we are going to use this shape to explain different properties of the waves, but this does not tell us that the only wave we have is the transverse wave. I said we consider the wave to have a sinusoidal shape or transverse shape in describing of a wave. The transverse shape is this shape here. I think you remember it. But why this? This is to bring about the simplicity of the concepts. Because if I'm going to use the longitudinal here, sometimes you can get confused. Now I'm using transverse to explain all other kinds of wave. Now to begin, let us try to look the first description. Let us try to look the first description. The first description is amplitude. The first properties which explain about a wave is called amplitude. You'll be asked to define what is amplitude. Amplitude is nothing but the maximum displacement of the medium from its equilibrium state. The maximum, look here, I said we are going to use the transverse to explain all the properties. Now look here. Now if this is x-axis is in x, which is meter, y-axis is in displacement, which is in meter, the maximum displacement, look, this is the displacement of this wave, this is the displacement, but also this is the displacement. But when we talk about amplitude, we talk about what is the maximum displacement. What is the maximum? From this point to this point is where we can measure our amplitude, because this is the maximum displacement of a wave from equilibrium positions. Now we are saying the amplitude can be defined as the maximum displacement of the medium from its state. This is the diagram as I have drawn already. This is the diagram of the amplitudes. Now look, this is the crest, this is crest, this is the crest. But where is the maximum among this 1, 2, 3? This one. Therefore, if you'll be asked to calculate what is the value of amplitude, you measure the maximum value of the displacement a wave undergoes. Now look from this diagram here. Look from this diagram. From this point to this point is what we call amplitude. But also a wave this for a complete cycle, a wave undergoes a certain displacement. A wave undergoes a certain displacement. Let us assume it is called y. Now look, from here to here is a, from here to here is y. How can you relate y and a? How can you relate y and a? Y, a, from this relationship here, a is equal to a half of y. Therefore, sometimes amplitude is a half of the total vertical displacement of a wave. Sometimes for you to calculate amplitude, you take the half of the total vertical displacement of a wave. Therefore, amplitude also is the half total vertical distance of a wave from equilibrium positions. Again also, wave's amplitude, look here, this is the amplitudes, this is the transverse wave. As you can see, from one point to another, the wave amplitude decreases. Now what can we say? Wave amplitude decreases with time, since some of the wave energy dissipate as heat. As wave move from equilibrium position, as wave moves from equilibrium position to another position, look here, waves moves from equilibrium position. Let's say it this way, that is maximum, but at it continue, its amplitude decreases. Why? Because some of energy is lost as it advances outwards. Therefore, as time goes on, the amplitude of a wave decreases. Why? Because energy is lost as heat as the wave advances from equilibrium state to another state. That is something which you can note from amplitude. Another thing which you should note about amplitude is about its SI unit. The SI unit of the amplitude is meter, but also the symbol of amplitude can be given by the symbol of capital letter A or small letter a, but mostly we normally use the small letter a. That is the symbol of amplitude. Now let us see one example on the questions concerning about amplitude, how we can calculate amplitude for the given question here. Let us look one example on how we can calculate amplitude. Now, for example, we have been given this question here. I can draw it here. This is the question have been given. The question for the wave goes up, down again here. Now this is 0, this is 2, this is 4. Now from this question here, you are asked to calculate the value of amplitude. What is amplitude? The maximum displacement a wave undergoes from equilibrium position. Now what is the value of maximum displacement here? The value of maximum displacement here, a wave it has, is 4. Therefore, what is the value of the amplitude? The value of amplitude under this question is 4 meters. Therefore, my student, this is how we can calculate amplitude, and this is what is about amplitude. Have a short break. We are going to meet later.